Hello, everyone. Thank you for participating in this session. My name is Ram. I am Senior Lead Data Engineer at Impetus Technology. So before we start this session, I wanted to extend my heartfelt thanks to my client partner, United Airlines teams, for taking the time and joining us and presenting this this session, which we have this project, which we have jointly developed. And this collaboration is basically a testimony of our collaboration throughout the last 6 and 7 years, which we are enjoying. And today we do have two leaders from United Airlines, Saurabh Agarwal, a senior manager in United Airlines, and Dheeraj Arora, who is a lead data engineer. Thanks, Saurabh. Your perspective definitely gonna add value to this session. Thanks. Can you please come and take over?
Hi, everyone. So, you ever had a flight delay and wondered what's happening behind the scene? Anyone? Well, today we are going to take that journey. Hi, everyone. I'm Saurabh Agarwal. I'm a senior manager at United Airlines. I lead data engineering for operations. My team works on building data products specifically for airline operations. So, United is a massive, right? We operate 5,000 plus flights daily and inclusion of 800 international flights. But at United, we don't just move planes, we move data fast and with purpose. Let me tell you why. In early 2021, we started our cloud migration journey as a part of Data Next strategies under the vision of our CIO, where he mentioned that the airline that make decisions faster always win. In fast-forward way, we completed our journey in 2024. But I would tell you one thing, migrating decade of airline data is not easy. It's not a drag and drop operations. We migrate 12 TB of data in fast-forward way. And when I'm talking about PB, it's a petabyte. It's not panic, though we had certain conditions during our migration journey, out of which UDH was born. UDH is a United Data Hub, which is secure, scalable, and centralized data platform, where everything connects. Your flight, your baggage, your crew, cargo, catering, and also the mystery. Why United Club is so close your arrival gates. Also, the connecting flights is just a walking distance. Let me tell you what's happening around the world. Everyone is talking about AI. AI is literally driven everything from your stock prices, your create music. Even last week I was hearing AI DJ made a cloud go viral in Ibiza. Interesting, right? So people need everything in real time, from your music, from food delivery, even the life decisions. So airline, we are not different. At United, we have a clear visions, and we have been working on, we are going beyond just storing your data. We are activating it. Our goal is to create a connected data fabric that includes domain-oriented data objects that can directly plug into the need of our business, so that crew data can talk to flight ops, and baggage handling can talk to gate agents. And for our business, they don't need to create or they don't need to wait for weekly reports, because they will come as ad hoc insights. And what is there for our customers and our business, for you guys? So we have been working on predictive delays before it occurs, so our gate agents can work accordingly. If our flight is delayed, we are able to re-accommodate all the passengers within sub-seconds, not in minutes and hours. And we are also working on AI/ML models. So for optimizing our gate usage, so that whenever a plane lands, it should directly reach out to the gates rather than wait for minutes. So these are some of the use cases where we have been working, but our overall objective is to create a customer satisfaction and also the operation efficiency. So now we have built the runway with UDH now. Now it's time to create a flight plan ahead. Our vision for data engineering team is very clear. We are going to unify all the data and then interconnected data object, and also use AI with generative AI to transform analytics into intelligence. So let me break it down, not in a buzzword, but in the business reality. We have been continuously working on modernizing our UDH platform to make a one-stop solution for all the data need. That means data is available, it's ready to use, and it's trustworthy. For that, we have been working on building a purpose-driven architecture that will suffice all the different type of use cases, from your gate availability to crew scheduling. And we want to make sure that no data running in silos, like crew data is there, baggage data is there, maintenance data is there. Our goal is we have a platform where everything can talk to each other, whether it's at the same time, we are also working on that domain-oriented data models, like we have IRROPs analytics, RCA, root cause analysis for a flight delay. As soon as there's a flight departed, if a flight is delayed, we are getting this insight at the real time. This is what we want to build like within real time. And once our data objects is ready, we want to build AI and ML on top of that, so that if we have this AI and ML on top of whatever we are building that data products, so that we are not only predicting the futures, we are also providing the actionable insights on top of that. To make everything should work, strong data governance is needed, because we want to make sure that we have a proper access credentials, data is secure, and it's readily available for users to access it. Now, let's talk about what really keeps things moving. Real-time data, real-time analytics that we have been doing. So, in airline industry, a delay of few seconds can be eyeball. So that our source data, we have, delay of single seconds can be eyeball, like your gates, the crew get out of syncs, and all of these things can happen once we are not getting the data in real time. So that means we need the data in real time, and we have the different sources, right? We have databases, files, all of this for making this. So we are getting data from all of these different sources, whether it's a API or we have these real-time feeds from from Kafka and all, and then we also having the data from some batch data sources. So once we have all of this data available, we are keeping that data into the data lake, and so we make sure that we have built a data lake where we are keeping all of this data. And once we have this data, we have a Medallion architecture where we are keeping that data in raw, curated, and the analytical layers that we have built. So we have these 3 different layers, keeping all the data is there, and over and above, we have a Databricks as a processing engine, which is easy to orchestrate the entire structure that we have. And once we have this, everything is set up, then we also have a UDH.ai that is like a generative AI layer on top of connected data fabric that I was talking in the previous slides. so that if any user is asking some questions like why a particular flight is delayed yesterday, so rather than analytics is going to create some, some sequels and then generate some dashboard, we want that business user will go and ask some questions. So like if like a particular flight got delayed or the boarding is something not is on the time, so everything is something we can get the answer from UDS.ai within real time. So the graphs and then the data and also the follow-up questions are ready for users to access it. That is where we are converting our complex analytics into the conversational intelligence. Now, let's paint a picture. You have packed your bags, you are reaching to the gate at airport, you get through from TSA, and you just take your favorite coffee, and you are approximately ready for travel. And suddenly, you got a message on your mobile that your flight for Houston 235 is delayed. So whether it's a dream vacation or business trip, nothing brings more frustration than delay. We understand that. Since I work on an airline industry, I got a role, I got my I role. So what are different factors? We always like, it's always easy to blame airlines, but story is not always the same. Sometimes there are two types of delay. The delays that airline can handle properly, and definitely we should do some better things there, like we have aircraft parts, or we have baggage claims, and then we have and then crew scheduling. Definitely we should work there, but at the same time we have some uncontrollable delays as well, like ATC delay, like weather, or FAA system failure, or we can say runway construction is going on, or any of the geopolitical conflicts that are going on. So we cannot do much on that. Even like in couple of last days or last week, we were also thinking during Memorial Day, we have seen that the data, there are around 1,400 flights got delayed. Why? Most of the reasons is because of the uncontrollable delay. That is, so that's the reason the flight were getting delayed, and the problem is that how we can solve it, because these are the uncontrollable delays. So what should we do? Just shrug, wait for things to be happened by automatically, or we should do something from there. Of course, right? We should have to do something here. That is where all the operation constraints, right, that I have listed it here, all airline departures and the ground stop delays and all of these things happening there. So what should we do? How we can handle it properly? That is where SWIM data comes into the picture. So SWIM data is always keep us ahead in our journey. So definitely, so instead of waiting for delays, instead of waiting for getting some issues, and then we can definitely take the help from SWIM data to reach to the next level. So next, I'll ask Ram to come here and then talk about what's the SWIM and then the future states.
So I do have a very valuable insight to be shared on the SWIM, but with the limited time, so I'm moving quickly. So bear with me as we dive in, right? Okay. So before we talk about like how SWIM data is being utilized in United to improve the overall operation efficiencies, I wanted to talk about like what SWIM is, what it is providing to us, and why it is a kind of a game changer in the overall aviation industry, right? So SWIM is a FAA-led initiative designed to facilitate a real-time data exchange to all the aviation stakeholders. That includes your airlines, your airports, air traffic controllers, meteorological departments. It could be a government entity as well. So instead of relying on a silos or fragmented system, SWIM provide a standardized way of sharing the data. And that sharing is basically, it's the FAA who control the overall SWIM, and that they ensure that this data will be accessible and consistent and secure by all the users. So SWIM provide a lot of information to us throughout the complete journey of the flight, from parking at the gate to the landing. So when your aircraft is parked at the gate, right? So the SWIM provide the information related to the flight clearance. That include your approved route, that includes your departure slot, which help a crew member to prepare for the departure. So from the beginning, we start utilizing the SWIM data from beginning of the journey itself. In the next stage of your taxi, so as your aircraft begin taxiing, the SWIM provide the information, a real-time taxiway congestion update that helps the aircraft in routing on the ground and to avoid any bottleneck on the runway. So the next stage is a takeoff stage, which is a very crucial stage and required like a precise coordination among the different entities. So in this stage, the SWIM provide the information related to the wind. It provides the information about the runway conditions. It provides the information related to the visibility at the runway. It also provides the information related to ATC clearance signal. Plus, it also provides the information related to the departure sequencing, because that sequencing is really very crucial to ensure that the departure will be happen in a orderly manner. Similarly, in the climb, cruise, and descent stage, we are also getting the information from the same related to the turbulence alert. We are getting the information related to the rerouting recommendations. We are getting information related to trajectory adjustments. So all this, like, there are many more to it. I'm just naming out some key information which we are getting out of SWIM. In the approach state, that is again a very crucial stage. In this stage, the SWIM not only provide the information related to the wind, visibility, and the runway condition, it also provide the information related to the space adjustment to the aircraft. Some people call it as a metering as well, and that also very important in terms of the landing of the aircraft, because that information ensure that how two aircraft should be distance each other before they land to the airport. So as your aircraft land to the airport, SWIM also support a smooth transition of the aircraft to the gate as well. So SWIM provide a lot of information, and that's utilized by our crew member, our ATC members, the ground staff, to overall optimize this complete flight, right? So all this information is basically segregated into a different category based on the area of functioning. So we have a different category, like a TFMS, flight and flow. The TFMS stand for the traffic flow management system. So the TFMS flight is provide the information related to the flight plan, the flight track, ETD, ETAs, and the TFMS flow provide the information related to the TMI. That includes the information related to your ground stop and ground delay and AFP. So whenever there is a ground stop applied on any of the airport, that real-time information is basically published by the SWIM itself. And my colleague Dheeraj will explain you like how TFMS flight and flow is combined together in United to implement a very interesting TMA use case, and we will definitely deep dive into that use case and give you insight about it. The next category is the ITWS, which is Integrated Terminal Weather Services. As the name suggests, this provide weather information around the terminal of the aircraft. Then we have a TBFM, which is Time-Based Flow Management System. So this provide the metering information we just talked about earlier, and as well as the TBM configurations as well. The SFDPS is a kind of a SWIM flight data publication service. In this category, we got the information related to special airspace usage or airborne holding and all. STDDS is a SWIM terminal data distribution service, as I said, the SWIM terminal. So it give you like information around the movement on the terminal, right? So through this, by using this STDDS, you will be able to identify whether there is the movement of the vehicle is like is registered with the FAA or not, or it is like a unauthorized vehicle running on the terminal around, right? The last one is the NOTAM, which most of the people know as is a like notice to airmen as well. This is service when FAA or any government authority wanted to publish the information related to the restricted airspace and the status. So once you, like after all the clearance and the approval, once you register with FAA, you start getting a massive flow of the data, right? All this based on the feed you are registered with. So if you're registered with TFMS flight, you might see like 380,000 messages you receive on the daily basis, which totaling like 40 GB of data volume. But if you're talking about the TBFM here, you can see it's like almost 100 times more messages you can receive on a daily basis, and that totaling around 16 GB of data. Though the number of messages is like 100 times more than TFMS in TBFM, but the overall volume is like 3 times less. And that because the size of the message we are receiving in the TBFM is very tiny, it's less than like a few KB. But in TFMS, we might receive the messages from 10 KB to 10 MB as well. It's a long, big message, XML message, which we need to pass. We will talk about this in the next slide. So the volume and the velocity is the one challenge. The other challenge when we were working on this use case is related to the complexity of the message itself. The XML messages are massive. They are nested at the multiple level. And each feed category like TFMS, flight, flow, ITWS, TBFM, all are following a different schema altogether. There is no relation between each in these feeds, right? So considering these challenges, like the data volume, the velocity, the complexity of the XML structures, we decided to build or architect our pipeline in the Databricks platform to utilize this scalability and the distributed computing power, right? So as you can see on the screen, we have followed a standard medallion architecture, which is generally recommended by Databricks as well. So through this architecture, we are processing the entire feed in basic 3 steps. The first step is to consume the data from FAA and read the XML messages, the raw XML message, keep it into the raw layer in the original format for the reference and the audit purpose. So that's the first step. The second step, to pass those XML message, convert it into the flattened structure, and then apply a cleansing rules to it. In this step, we are also applying a data quality rules as well, right? So once the cleansing happen, flattening happen, data quality rules are applied to the data, we are storing it to the curated layer. Some people call it as a silver layer as well, right? So once the data is curated, the next layer is an aggregated layer, or you can call it as gold. So here we are applying our business logic to aggregate the ingested data, and that ingested data is basically moved to the other rest of the system so that our business analytics team can join that data together with other feeds as well to get the insight or convert the overall data into the knowledge, right? Some of the very interesting use cases we have already implemented, many more to go. Couple of them we definitely wanted to share with you to give you an insight what information, the knowledge we are getting out of it. I will invite my friend Dheeraj over the stage to brief you about that. Thank you.
Okay, thank you, Ram. Hello, everyone. So in the last few slides, my colleague Saurabh and Ram explained you about United approach for data centralization. operational challenges that a airline face, and also we saw an overview of SWIM data and the different variety of data it possesses. Now in this section, we will see how we are leveraging SWIM data to generate actionable insight and make operations smoother, okay? So first of all, a question to you guys. How many of you have a flight delayed due to weather? Right? Almost everyone. So, weather is not just one of the delay reason. There are multiple uncontrollable reason that a airline deals with. So first one is weather-related delays. It can be due to thunderstorm, volcanic ash, and then the second is airport capacity, which can be due to track congestion, etc. And then is airspace congestion, which can be due to a public holiday like Memorial Day, which just passed up. We saw in the last few weeks. So how an airline deals with these different varieties of challenges. So here where TMI comes into picture. TMI, what is TMI? So TMI is a traffic management initiative which deals with taking care of these scenarios where a capacity is less than the demand, okay? So there are majorly two types of TMIs which happens. So on the top side you see, right, in the left blue color it's GDP, and on the dark blue color it's GS. So GDP is ground delay program. It usually happens at an arrival airport where flights are delayed at their departure airport. Then is ground stop. In this, it's a severe type of TMI where flights are halted for temporary purpose, okay? So now in this matrix, we will see on the left side, you see these are different airports, and then from left to right, it's a time range. This all data is for 1 day of data. So you can see in the second row, right, for Dallas airport, there was a TMI which was implemented due to a volume constraint. So this constraint usually happens when the volume, or basically volume is very huge, which a particular airport can't deal with. Next we see at a EWR airport, there is a TMI happened. Firstly, it was a ground delay, and then in between there was a ground stop, and then again a ground delay happened. Also in the second last line, we can see at the Miami airport, there was a TMI happened due to thunderstorm. Okay, so here we see that a summary of the TMI has happened for 1 day. So how is it benefiting us? Okay, so in this case, we can see that we are, it is giving us different reasons and how we can take care of that in the future. So that is what an overall objective is. Now, there are few more insights we are further generating from by leveraging SWIM data. So starting with is the airport throughput. So on the left side top, right, it is giving you total departures and total arrivals that can happen, that are happening at United States for different airports for some time range. So here if you see, right, if there is a large gap between departures and arrival, then it's a red flag. Probably because some kind of a disruption is happening up, right? So what we can take benefit of this data? We can have proactive measures that to make diversion so that we can improve customer satisfaction and all those things. Next is holding pattern, right? You must have observed that right, when you are flying, there are a lot of flights are keep on hovering over an airport, right? This is what a holding pattern is. So here what we are saying that total number of flights which are in the holding state for a day for United. So with this we got the scenario that these many flights were in the holding state. But how we can in the future take benefit of this data and further improve this efficiency so that we can improve the customer satisfaction. Next, over here in the below left side, right, we can see how many diversions have happened in a day. So there are we can see that overall total 6 diversions happened. Out of that, 2 were happened due to TMI. TMI, what we all saw in the last slide. Then is return to block details. It is basically when a flight started from a gate, but then it came back. It can be due to mechanical reason, or it can be due to taxiway congestion. So we can see that there were 5 flights which were impacted due to TMI. So all this data, basically we are getting up from the SWIM, TFMS flight feeds, TFMS flow feeds, and then we are generating these all actionable insights, which is helping us improve our operational efficiency. Last one is TOS. It's an interesting thing. It's a trajectory option set where a particular airline gives an optional route in case of weather disruption, so that our arrivals happens, and then a particular flight can land at that airport. So we can see that we filed up 3 TOS for a day. And then there is also a scenario where FA mandates or implements a TOS in departure is less than 45 minutes. So, and also we will see how many were successful and all those things. So this is overall different actionable insights that we are generating from SWIM data. So United is not just collecting the data, we are connecting this data, right? From diversions to delays, holding to airport throughput, and generate real-time values out of this data, which can improve operational efficiency and make customer happy like you. Yeah, so this is at an overall level or different insights that we are generating from SWIM data. And now back to you, Ram.
Yeah, thank you, Saurabh and Dheeraj, for sharing your thoughts on this. Really appreciate. So, a little bit about the impetus technology, right? So this is something we have recently awarded by the Databricks, the Enterprise Data Warehouse Partners. Very recently we got awarded with this certification. So here, right, so we have a very deep relationship with the Databricks, and that is proven with the certification we have won. And we have also very a deep Databricks competencies as well in our organization. We have like almost 350 Databricks certified engineers working with us and helping our business partners in implementing different use cases. Okay, so I am not gonna talk about all because we are almost top of the hour. I just wanted to say that we are the full data service cloud engineering company. In the Databricks community, we are basically known for the 2 reasons. The one thing is migration with our proprietary accelerator. We call it as a leap logic. So that's our in-house product, which we have built. And that is very useful in the data migration and onboarding our partner to the Databricks platform. And the second one is related to the GenAI ML use case development with our Data Lab offering. In other words, we can help you get Databricks, and we can accelerate your data journey with the GenAI use cases all the way to the productions. Thank you. This is our booth, F603. Please do visit us there, and don't forget to provide the feedbacks. Thank you all. Thank you. Thank you for joining.